Transformation of trigonometric functions. Question 1. Sketch a cycle for each of the sine function. State transformation from parent function. Well, that's my first video on sketching trigonometric functions. Now, I have kind of a different approach to sketch these functions, and somehow I like it very much, and I hope you will appreciate it also. Now, few things I want you to understand when you read a question like this. First thing is the word sketch. When we are trying to say sketch, it doesn't mean graph. That means accuracy is not an issue, right? What you should just give salient features or the main characteristics of the function while sketching, right? Don't waste your time in making it very accurate, right? In that case, the question should have been graph a cycle for each sine function. Do you understand? It is only a sketch, not a graph. And the rough sketches which I'll make as a part of solution for this will be good enough for you. Okay, so treat sketch as a sketch. And the second part of this question is state transformations from parent function. So there are basically two parts for this question. State transformation from parent function. Many times I've seen students wasting time in making a beautiful graph and then forgetting to write down the transformations. Well, it happens, when you get so much involved in graphing, it may happen that you may forget what the question was. So my preference is first write down the transformation so that we totally avoid missing out on one part. That is, sometimes you may just not write transformation. So let's get half of the marks of transformation at least. Very simple transformation here. Vertical stretch by a factor of 2. It is important to write factor of. That means it is getting multiplied by, right? In translations, it moves left, right, up or down. When you multiply, then that number is a factor, correct? So, vertical stretch by a factor of 2. So that gives you half of the marks at least, right? Now, the second part is sketch a cycle for each of the sine functions. So let's try to sketch a cycle. And this is one of the most beautiful way sine function can be drawn. Sine function is kind of like this, right? That is your sine function. Just draw your sine function as it is. Now look into the problem. The problem says y equals to 2 times sine x. That means the amplitude is 2 and there is no other transformation, no shifting here and there. So we can straight away draw our x-axis and y-axis. That is kind of my x-axis and this is my y-axis. So I got my y-axis and x-axis, and important things which I need to mention for this sine function is that the amplitude is 2. So it is plus 2 here and that is minus 2. This of course will be 0, right? And so that gives me the amplitude. Now along the x-axis, this variable, we have time period, right? And the time period is x. So those of you who are doing in radians should write 2 pi. So I'll write 2 pi on the top. And those of you who are doing in degrees should write 360 degrees. 360 degrees for that, and so this is 180 degrees, correct? And the ones with radians will make it pi, correct? And those ones are half of pi, which is pi by 2. And this is 1 pi by 2, 2 pi by 2, and 3 pi by 2. 3 pi by 2. So that is your scale, horizontal scale, correct? And well, and this is 90, and that is 270 degrees. So that is a perfect sketch, and you can't go better than this. It's not expected in the test, right? So, and don't forget to write y here. Sometimes they'll write f of x, then write f of x there. So this function represents 2 sine x. That means, and the vertical stretch. I hope you get it. It just takes a minute to sketch this and a minute to write down all other things. Label your sketch. That is most important, correct? Now, so don't try to make a table of values with 0, 90 and plugging all those values and connecting them, there is no point altogether, right? That is it. Now let's look into the next part. So next part is, well, write down your transformation, and third, write down your transformation, correct? Here the transformation is 1 unit down, that is all. So vertically move 1 unit down, and here you'll write down transformation, which is reflect on x-axis, correct? So it is reflection on x-axis, correct? So that is what you'll do. And here the transformation is translate 1 unit down. So vertically 1 unit down. So that's it. And now sketching. Sketching, I will again show you here, minus sine x. That means this wave, instead of rising first and then falling, will go in the reverse direction, right? So we'll go like this. Is that okay? So that is fine. And there's no other transformations, things like that. So what we'll do is we'll just draw our axis like this, as we did in the last time, correct? And this is your function y. So you can write x here, y here, 0 here, and all those things which we wrote here. So I'm not writing all those things now. You understand whatever your units are, I'm just writing few of them. But this is kind of important. Always, at least time period you should give, right? -1. That means amplitude is just 1 and -1. That is a good enough sketch for the given situation, right? And last one is translated 1 unit down, correct? Now if you translate your graph 1 unit down, so let me do this thing first for you. So what we will do is I'll sketch it here for you. So this is my sine graph. So I'll again draw my sine graph. Perfect. Now I know there is no horizontal shift and all, so my y-axis is kind of here. So that much I'm very sure of. That is my y-axis. But I know that my axis of symmetry has changed, right? So what I will do is I'll write down where my axis of symmetry is. So that is my axis of symmetry. So I'll draw a dotted line along the axis of symmetry. And at this point, I know this is -1. So I'll write -1 here. So let me use this ink and write -1 here. So on my y-axis, this is my -1. Now since the amplitude is also 1, so 1 more than -1 will actually give me 0, right? And 1 less than -1 will give me -2. Now if that is my 0, obviously my x-axis should go from here, right? Touching this, right? So I should have touched this all together. So that is my wave. Do you see that? Now, so I have this as my x-axis, that's my y-axis, and just to give a scale, I'll give +1 here, and I've moved my sine wave 1 unit down. Do you see that? Do you see that? So that is, I think, most beautiful way of sketching sine graphs, right? Now, a question could have combination of these. For example, I'll give you now a problem. What you need to do is just combine all of them, right? And your question for practicing this is basically write f of x. So instead of y, I'm writing f of x. So you should write f of x here on the y-axis, correct? And then I'll do -2. That is taking care of minus and 2. And then I'll do sine x -1. So instead of -1, I'm just changing it to +1. A very minor change I have done. I'd like you to sketch this graph, which is combination of these graphs, correct? Except for this statement, we're just moving it 1 unit up rather than moving 1 unit down, correct? Now once you draw these graphs, also write their domain, range, and time period if possible, okay? So time period for all these graphs is just 360 degrees or 2 pi, correct? But there is a slight change in domain or range, right? Okay, not much. But range, yes, already, that's fine. Range, minor changes, otherwise it was same there. But I hope you get the concept of this. In the next video, we will do, some variation on these transformations with cosine function. And then I'll take you to the next level, where we will do some horizontal stretches in compression and changes in time period. I hope you understand this. Get a grip on this, and then we move forward. Okay, thank you.